So following on from the previous video, you don't always have to sum up cylinders and discs. You can sum up squares as well, and then you can also sum up rectangles. So in this case, we are summing up all the rectangles here. So remember, if this is A, from here to here is A, then the height here must also be A. Okay, so to work out the volume of this solid here, you don't forget you are moving along here. So this is your well, you got to take the integral from 0 to 5 here because of this. So it will be you doing from 0 to 5, and it will be something something dx because you are moving along the x direction here. Okay, so what is the area of this rectangle as we move along as we move along the x-axis? What is the area of this rectangle? Well, the length here, this length here, is given by this. Okay, so let's just concentrate on finding this length here. Okay, so this length here would be us rearranging this. So it would be 5 squared, take away x squared, and then square root it. So we should do that, but we're just going to consider the positive. Okay, so this height here is given by this, but then we've got two lots here. So we need 2 times this. So it would be the integral of 2 root 25 minus x squared. So as x is moving along, the height here, the total length here is given by 2 times, well, it's given by this here. Okay, and then we need to, so we've got the length here. We now need to find out the height of this plate, this rectangle. We need to know the height of this rectangle. Well, the height, well, as x is moving along here, if from here to here, let's say it's x, then the height must also be x. So the height, this height is also equal to the length as you move across. So the height of the rectangle is actually x. Okay, so it's you integrating. So this thing here will give you the volume of this solid here, So tidy this up. So that will then take you to the total volume is given by the total volume for this thing here is given by this. So basically it's what we had earlier, but so the total volume is given by this. And now tidy this up, move this across here, so it looks like this. And then rewrite this as this to the power of a half, and then now integrate. Okay, so when you integrate this, you are really looking for something. That when you differentiate it, it will give you this whole thing here. Okay, so your eyes should zoom in. Hang on. So to integrate this. Let's imagine that at the moment you've got something to the power half. So you've got this at the moment. So to integrate this thing here, make your initial guess to be this. 25 x squared. Make your initial guess to be this. So hang on. So this is going to be our initial guess. So when we differentiate it, hang on. So don't forget, this is our initial guess. Differentiate this, and it will give us 3 over 2 25 minus x squared to the power of this gets minus by 1, and then we've got to times with the derivative of the bubble itself, which will be negative 2x. Okay, so you notice that this being our initial guess, when we differentiate this, it would give us this. This is very similar to this, with the exception of the minus and this thing here. So make our adjustment. Let's negate this first. So negating this will be us doing this. 2 over 3 Okay, so now and then we need to kill off this 2, so make this adjustment to be this. So now if you differentiate this, it will give you this. Now it will give you um, it will give you this. Well, when you differentiate this whole thing here, it will give you this. Okay, so basically integrate this and it will give you this. Okay, which is this. Well, hang on. So integrate this and it will give you this. Okay. So now evaluate this. So when you put 5 into here, 5 squared will be 25. So it's 25 take away 25. It will be, well, the whole thing here will be 0 here. Okay. And then take away. Now put 0 into here, and then blah blah blah. It will give you this, and then blah blah blah. The overall volume will be this. Okay, so this here is the volume for 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 this. Okay,